Okay, let's take a look now at some of the physical properties of Venus. Venus is sometimes referred to as our twin sister planet um, because on the big scale, it's so similar to the Earth. Look at that, 95% the diameter of the Earth. I'm sure if you just see them in space together, they look identical. 82% the mass of the Earth, which of course you combine those, it means the surface gravity is only slightly less than Earth's. So very, very similar on the big scale, but that's about it. I mean, that's when the similarities kind of stop. That and the density is very similar. You can see 5,200 for Venus, about 5,500 for Earth, about 5,400 for Mercury, so it fits right in. But from this point on, we'll be talking about differences. So at first glance, it seems like our sister planet, of course. The first thing you come to, though, that is wildly different is the rotation. Again, this was difficult to measure because of the clouds. They had to use radar and so forth, and they found that it rotates once every 243 Earth days. Think about that. The Earth spins around 243 times in the time it takes Venus to spin around once. It is almost stopped. It is the slowest spinning planet. Now that's how long it takes to spin on its axis, which is what we call a sidereal day. It is the slowest spinning planet. And then when you actually look at, let's say from noon to noon, what we call a solar day, well, it's still a long, long time. 117 of our days go by, and you have one day if you're waiting from noon to noon. So look at that. It only takes Venus 225 days to actually orbit the sun. And so you're looking not even quite 2 days a year. There are 2 days a year that go by on Venus, which is still better than Mercury, which was even stranger, where you had 1 day takes 2 Mercury years. But in this case, you get not even quite 2 days in a year on Venus. Very interesting. I'll show you a quick graphic here of how this works out. But again, because of that super, super slow rotation, if you just follow my cursor here, if we start here at 0 and go around, so look at that. At this point, you're halfway around the sun, okay? Half a year has gone by, and finally, look at the arrow here pointed at the sun, that's noon. Look at the arrow here, that's noon again. So when it's noon again, already just over half of your year has gone by. That's kind of strange. But that's not even the strangest part, I think. The strangest part is this. It spins backwards with respect to the other planets, to the other 7 planets, which is really, really interesting. Now, I have this ongoing joke in my classes that when astronomers can't explain something, there is a default answer they always go to. And that answer is simply this: something smacked the hell out of it. That is kind of the default thing. We just say, hey, early in the solar system, when everything was smashing into everything else, okay, it got hit by a large object. And that's what we think here as well. So just like Earth, of course, got hit by a Mars-sized object, and we got a piece of us chipped off, which became the moon. In this case, Venus, it just about stopped it completely from spinning and gave it just a very slight retrograde, backwards spin. And for the record, things get really weird. But because it spins backwards, there's really no north and south in space, so we base it on the spin of the planets. So for example, if you use what you call in physics the right-hand rule, if a planet spins this way, maybe you define that as north. So for Earth, north, Mars, north, Jupiter, north. But for Venus, you'd actually have to turn your hand this way, and guess what? That means that on Venus, north is down. So like on a map, in other words, compared to the other planets, north is actually at the bottom of the globe, at the bottom of the map, which is all just kind of funny, kind of interesting. All right, the atmosphere of Venus, as we mentioned, it's cloudy all the time. It's a super dense, thick atmosphere. It does have a jet stream going around it, just like the Earth does, and but with some slower, very slow surface winds from the little bit that we know. But it does have a jet stream like us. And then as far as temperature goes, there's this great video of a young Carl Sagan, the brilliant astronomer and teacher. And this video of Carl Sagan back in, let's say, the 1950s, talking about the temperature of Venus, how it might be very Earth-like. Well, that ended up being kind of embarrassing. Now, the reason they thought that, of course, if you look at the size of it and its distance from the sun, you could kind of think, okay, well, maybe this will be a fairly pleasant place. Maybe it'll be kind of like, it'll be a hot world, but more like, like a jungle world or something like that. But anyway, they were a little surprised when they actually finally got the actual temperature and found out that it is, about 850 degrees. And by the way, that is, number one, the hottest planet in our solar system, actually hotter than the hot side of Mercury. And unlike Mercury, which has a hot side and a cold side, it's just hot everywhere on Venus, just unbelievably hot. That thick atmosphere acts like a blanket and just traps that heat everywhere all the time. So obviously it wasn't a jungle. They thought it might be an ocean world of some type. Obviously not. It is a just smoldering desert. It's a rough place, as you'll find out throughout this chapter. And again, we'll throw in a little art here. Another famous painting. This is the Birth of Venus, or as I like to call it, Venus in a Clamshell. Now, the Birth of Venus by Botticelli, who was a contemporary of Da Vinci in Florence. So the Birth of Venus. And I think both the Venus de Milo no, I might be wrong about this one. I know the Venus de Milo is in the Louvre, and I think this one's actually in Florence, if I remember right. The Birth of Venus. And anyway, back to the science here. No magnetic field. Now, if you've been paying attention, that should not be a surprise, because there are two main things you look for a strong magnetic field. Fast spin and molten core. Well, Venus has a molten core. I mean, it has, active volcanoes and so forth, but obviously it is the slowest spinning planet, and therefore there's no global magnetic field. You couldn't use a compass, for example, on the surface of Venus. This is a bit of a mystery why Venus, if it's so Earth-like on the big scale, why there are no plate tectonics, but we've not seen any plate tectonics on Venus. So it's, again, another difference with the Earth there. And so there's the big scale again. And you see if you can dunk a basketball, a 10-foot goal on Earth. Okay, you can dunk on an 11-foot goal on Venus, but it's not too much different. Just about the same size as you can see down here. Just about the same size. So it's very misleading because the size, the mass, the density all are very, very similar. But obviously Venus turned out quite differently, and that might be a lesson for us here on Earth about our own planet. But we'll get to that. We'll get to that later. Hey, thanks for listening.